All right, for our next section of basic static analysis, what we are going to talk about are strings. Now, what is a string? In the computer science and programming context, a string is very, very simply an array of characters, right? So while you and I, as humans, understand something like a sentence that might say, hello, world, a computer doesn't really get what this is. It doesn't have an idea of what a word is. It doesn't really have an idea of what a phrase is, but it does know each of these individual characters. And so strings are very useful to humans, but not so useful to computers. But humans need strings in programs to do lots of different things. If you think about maybe a programmer is trying to get a program to talk to https://google.com, that is a string. A computer is not really going to know what that is, but it will treat it as an array of individual characters. So it will say, this is the 0th part of this array, this is the first, this is the second, the third, the fourth, the fifth would be the space right here, 6, 7, 8, 9, 10, and then there's actually one final part right here, which is a null byte, which means that it is ending the string and saying, this is the end of the string, don't go any further than this. And so that would be the 11th element of the array. So that's a little bit of background about what a string is to a computer, but what does it mean to a malware analyst? Well, like I just said, if the malware author wants to program the malware to reach out to https:// and then this could be any malicious domain .com/ and then this could be evil.exe. The malware author needs to code this into the program at some point so that the computer can assemble this array of characters into a string and make some kind of web request to it. And this comes in the form of a string that is embedded right into the exe. I want you to think of an exe as kind of like this box, right? And so when the box is assembled or compiled, there are lots of different bytes that are inside of this box. And one of those bytes might be http://domain.com. And so if you can reach inside of this binary and take a look at the strings inside, it might inform what the binary is doing. But you can't really draw any absolute conclusions out of this. The best that you can get, really, out of looking at the strings is a brief glimpse into what might be used as a sentence or a phrase or a word or maybe a URL inside of the binary. Now let's take a look at how we can extract these strings out of the binary. Now, as I previously mentioned, when the binary is assembled, these strings are kind of just sitting inside of the binary and can be read by looking at the bytes of the binary. And we don't have to run the binary to do this. And so we can extract the strings out during the static analysis phase. There is a program called strings that will do that. It'll look at the binary and pull out all of the strings, the arrays of characters, and present them to us. But there's actually another program that I like to use a little bit more, and it's called FLOSS. So think strings, FLOSS, it's like a better version of strings, which is made by the FireEye team that is going to do just that. It will pull the strings out of the binary, but it will also try to decode and deobfuscate any strings that it finds with a little bit of programmatic magic on the back end, and then present us the strings at the bottom of the output of this program so that we can more easily get an idea of what the strings are inside of this malware and what we might be dealing with. So again, we will do our malware.unknown.exe.mal, and we'll use the program FLOSS and hit enter. And so depending on the size of the binary, this may take a little while or it may be pretty much instant. And so this binary happens to be pretty small. So what you see here is FLOSS takes a look at the bytes inside of the binary and it pulls out any array of characters that are greater than length 4. Now, it will treat that as a string and say, hey, I found an array of characters that is larger than 4 bytes and here it is, and it's terminated with a null byte. That might not be great always. Now we can see some of these strings are completely useless. This doesn't mean anything, right? This is just a random array of bytes inside of the binary that may be serving some kind of programmatic function, but it doesn't really tell us a lot about the words or the phrases or the URLs that are used inside. So the idea is that not all of these are going to be useful, but every now and then you're going to come across one that's incredibly telling. As you can see here, I didn't really do a lot of modification when I was writing this malware, so you can actually see the exact path of the malware in my repository from the original compilation. My pmat maldev repo right here is where I was writing all of this malware. Now, you may get very lucky and see something like that, but you can just kind of keep scrolling. And after you get through some of these other less useful strings, you start to see some other things in here. And this is actually it ties into another part of the static analysis phase that I'm going to cover later. But you start to see these things like internet open URLW, internet open URL, win.inet.dll. To a trained malware analyst, some of these are jumping out immediately. URL download to file W. Now, to someone who's not really familiar with what this could be, what could these things be? Well, maybe they are the names of functions, or maybe they're the names of things that the binary is doing. And as we keep scrolling, we see a few more of these, and then eventually we get to the very bottom of FLOSS, where FLOSS is going to pull out the static Unicode strings. And these sometimes are some of the most telling of all of the things that FLOSS will pull out. And so we see things like cmd.exe, and then cmd looks like it's running some kind of command here. And we see things like http://SSL, and then maybe like a domain name here, helpdeskbros.local/favicon.ico. We see something in the user's public documents directory right here. Now, what we should be careful here is that these may be thrown into the binary intentionally to trick us, or they could be actual pieces of the binary's functionality. We don't know at this point, but certainly all of this right here is very interesting. And so what we want to do is take note of this and maybe think of it like putting a pin in this right here. So we're going to take like a little pin, and we're going to put it right in that cmd.exe and say, I don't know what this string is doing, but now that I know that it's in there, I'm going to take a look at the things that are using this string and maybe some of the stuff that happens around it. And so we see some very interesting information here, but again, at this stage in the analysis, there's just not enough to go on. We really need to start to go deeper to figure out what these strings are doing and why they're in here. But in any case, extracting the strings out of a binary can be a very informative first step at identifying where to go next. So it's very important to do. So that is string extraction, and we're going to be moving on to our next section of the static analysis. So meet me in that video.